Okay, question came before class. I see the midterm coming up. What do I have to do to get ready for it? So here we are. It's February 2nd. The midterm begins on February 14th. And then you've got, let's see. So you've got that week. So get over there sometime. I think if that's when it ends, I gotta check and see when the late day is. There's going to be a late day. I'm not sure if it's Friday or if it's the following Monday that the late day is. I'll check that and then let you know as we get closer. But here's how to study. So a week from today, I've put on the schedule this study guide. So what I did was when I was making the study guide, I went back through the chapters that we've covered. And I said, all right, let's see. Term study guide. Okay. So kind of starting here on page 2, said, all right, I'm kind of going back over the chapters that we've covered and said, all right, what are the sections from this chapter that I want you to be familiar with? I don't know how many sections there are in chapter 1, but I'm only interested in sections 5 and section 8. So kind of go back and look at those, make sure you're comfortable with those. What am I interested here? Understand the 3 options available for recording a macro. Right, you can put it in the personal macro workbook. You can put it in this workbook or a new workbook. What's the difference between the 3 of them? Why would you choose one versus the other? Difference between Xlsx and Xlsm files. What's the difference? Yeah, you can't put a macro in an Xlsx file. You've got to have an Xlsm file. So if you have a file that ends in Xlsx, you know that's not a macro-enabled workbook. There's no macros. Okay. So that was how I built the study guide. How can I help you figure out what to study? Let me look at the things in the chapters that we've covered that I think are important. Then when I made the test, I looked at the study guide and I said, okay, here's the first thing I said they should know. How can I write a question that tests that? Here's the next thing I said they should know. Here's, I might get to one of these things and went, that's too hard to write a question to see if you can know it. So there's not necessarily going to be a question for everything on the study guide. But you're not going to find anything on the test that's not talked about on the study guide. I mean, that's how I built the test, was by looking at the study guide. Now, there's going to be 2 kinds of questions, and that's what we show here on the first page. So first of all, the whole test is multiple choice. It is pencil, multiple choice, fill in. You're not going to have a computer with you to take the test. It's just, have you learned some stuff that I want you to learn? And there's some of this stuff that you are better at because you've done some study, like all this stuff about variables and data types. You're better at this if you say, yeah, I'm somewhat familiar with the data types here. So I don't care that you're like so specific. What's the range for integer? It's negative 32,767 to positive 32,768. I don't care that you know that, but I do want you to know that's roughly 30 plus or minus 32,000. So if you're thinking, is this the right variable type for me to use, data type for me to use? I can get there. So if I gave you a question that said you've got to be able to store data that ranges anywhere from 1 to 50,000, but only integers, what data type would you use? Could you use byte? No, the range is 0 to 255. Could you use integer? No, it's plus or minus 32,000. So you got to use the next one bigger, which is long integer. Yeah, just long. So I'm going to, that's stuff that you are better at programming because you've taken some time to study it and get to know it. And that's mostly the stuff that I'm going to try to quiz or evaluate you with these kinds of multiple choice questions. In the following code segment, what does font refer to? So is font an object? Is it a property? Is it a method? Is it an event? We haven't talked about events yet, so chances of it being an event are really, really slim. Is it a collection? Is it both an object and a property, both a property and a method, both an object and a method? What do you think? Any idea? I just saw you make a little plus. Were you giving it some kind of a hex or a curse or something? What's that? F, both an object and a property. Oh, yes, very good. So I can tell that it's an object because it's got something to the right of it, right? So if I see dot and then anything to the right of it would go, all right, whatever is on the other side of that dot has to evaluate to an object. So anything to the right of a dot is either a property or a method. What's the difference between a property and a method? A method is something the object knows how to do. It's an instruction to do something. And here, we're not doing anything. We're just referring to the font. It's not like we're creating a sheet or changing something about a cell. We're just referring to the font property of a range. And that is a complex object. It's got properties of itself. So that's right. It is both an object and a property. So that's going to be one kind of question where you've got multiple choice and you just got to give me an answer. The other part of the test is going to be like this. So here is an example sub procedure. And I think I tell you something on the test that says, like, you know, when you look at a block of code like this, you can assume that you are looking at the only code in the whole project. So this is all there is. I'm seeing a sub called proc1 sub and m sub. Oh, actually, this is what we're going to be talking about today. So this is conditional branching. So we declare an integer variable. We put the value 5 into that. Is 5 going to fit in here? Yeah, integer, plus or minus 32,000. So that's going to go in just fine. Now, this is going to put a value into range A1. This test is, now, if x is equal to 5, is this condition true? That's true. So we are going to drop into this, and we're going to change what's in A1. What was in A1 before? This test is, and now it's going to be what it used to be plus or concatenated with ugly. So at the end of this line, we're going to say that cell A1 is going to say this test is ugly. Now we're going to change the value of x. So what is x going to be after this line executes here? Now it's going to be 10. So now we get to this else if, is this condition true? At this point, this condition is true. So the question is, are we going to execute this line? And I wouldn't expect you to know that until after you've prepared for this class and maybe sat through this class. Because when you have an if statement where you have if and potentially multiple else if clauses and an else clause, these are all mutually exclusive blocks. As soon as one of them is true, the code will be executed in that block. And then when we hit the else if, we don't even look at the expression. We're done. We drop to the end if. So even though this condition is true, this block of code won't execute. And so in A1, it's going to say this test is ugly. So C would be the correct answer on this question. So it might be a good idea to bring some scratch paper and a pen. You'll need a pencil for sure because it's multiple choice. But bring some scratch paper because, you know, you might want to say, all right, you might actually want to draw out, like when you're taking the test, all right, X. You'll put a little square on the paper, label it X, and when you see a statement like this, you've got to pay attention to what's going on. When you see this, you can go, great, that puts 5 into the value of X. You can kind of step through and see what it's going to do. Okay, questions? Let's take a quick look and see what the actual, when the late fee begins on that test. Scheduled dates. I think this will show it to me. This is 5/20 midterm. Yeah, so late fees start on Friday. So that Friday, you got to pay $5 for the privilege of taking the test if you do it on Friday. Otherwise, you've got Monday through Thursday to take it for free. Okay. Does that answer your question about maybe how to prepare for the exam? Good. Other questions about the midterm? Folks, you should take preparing for the exams pretty seriously in this class. Because I give you two submissions for all the homework and the projects, the truth is that most students get really high scores on their set of projects and homework. And so most of the distribution from this class is driven by the exams. So the exams are not, they're not a walk in the park. There's usually a handful of students that get full marks or really, really close to full marks on the exam. And so there's a handful that do really badly. So take it seriously, prepare for it. Recommend that you get together with a study partner and maybe even come up with a few questions like this, as you're looking across the study guide, how can we write code to see if you can study that and get some practice working with questions where you've got to evaluate code. All right, today we are talking about conditional branching. So I've downloaded the file from not September 29th, from February 2nd, making decisions in VBA, and that will go ahead and start working with that data. That's not it. So here's the data that we're going to be working with today. These are food establishments in the city of Chicago. So there really is a place called Duke's that is located on that location, on that address in Chicago. Oh my gosh, it's a high risk. Why is Duke's a high risk? Is it because they have bad practices for handling food? No, it's because they're preparing food that can go bad in a way that will kill you if you eat it. How could you be something besides not a high risk? Who's this? Who's a medium risk here? McDonald's apparently is a medium risk. I'm not sure why they're medium risk. Let me find a low risk. Grocery store is a low risk. So Dollar Tree grocery store is a low risk. Why? They're not cooking up raw meat in the grocery store. They're selling some things that you would, eat that's kind of ready to eat, but the stuff that they're doing is not that bad. Okay, so anyway, just some data for us to work with. Let's go ahead and get into some code. So it looks like I've got a module here already, but there's nothing in it. So let's go ahead and make ourselves a sub procedure. Let's take a look at the if statement, sub if demo. We've already played a little bit with the if statement, but we haven't really kind of had a formal discussion of it. So I'm just going to go ahead and put together a loop that will go across all the data that we have here on our, actually, why don't we look at the violations sheet? So this violations sheet is just a subset of some of this data. I'm not even sure what I use to define this set. It's not very many, like less than 300 records. But this really is like a comment that a food inspector in Chicago gave to someone. Premises must be maintained free of litter. I think they're actually re-putting the requirement here and adding the comment separately. What does it say? Comments abated. All storage rooms must be properly maintained, free of clutter, must elevate, get things more than 6 inches off the floor so these can be properly cleaned and serviced. So this then is just, as inspectors, food inspectors are going through the process of checking to make sure everything looks good. They say, you know what, you're not quite doing this right. And then here's the violation. By the way, we're going to charge you a couple $100 for it. Better get it cleaned up, or next time it's going to be a lot more. So I'm just going to write a loop that'll go through this data. And if we look over here, we'll see that that worksheet has a name, has a code name of violation. Zoom in a bit there. So violations in parentheses is what shows on the tab. To the left is what actually I can refer to it in code. So I'm just going to go ahead and use that. Let me go ahead and declare a variable. I'm going to call this row as long integer. I'll initialize it to 2. So row equals 2. And then we'll do a do loop. We'll do events in there. That increment row. And we'll do until violation. It's a violation sheet dot cells row number row column number 1. You're going to continue doing this loop until that expression is empty. So the value of that cell is empty. So that's just going to, so this loop is just going to execute that many times. Let me go ahead and just print off row here, debug.print row. And that will print off 298 values, but kind of give us the background that we need to kind of look through this and play a little bit with the if statement. Okay. Have we already? I don't think we've used string functions yet. I'm going to introduce something that's coming up. I think built-in functions. I think it's the next time we're going to get introduced to using functions to manipulate strings. But we're going to use one today because it'll be really helpful to us. It's called inString. Let me just go ahead and show it to you. So there's a function, built-in function, part of the VBA language called instr, inString. So just like functions that you would use in a cell, this function, I'm going to give some parameters to it. It's going to give me a value back. So I'm going to tell it, this is going to allow me to find one string inside of another string, which is why it's called inString. Now, the arguments that I give to this function come in, I think, a little bit of a strange order. The first one is, where am I going to start looking in the string? And I'm just going to say, start at the beginning. So start at the first character, and then I'm going to look in some string. So I've got some string to look at, and then I'm going to look for something. And that should be enough. There's actually one more argument that we're going to talk about, but I don't need it yet. So this says, hey, is this string Nephi in this string right here? And if so, where is it? So that is the 1, 2, 3. That's the starts at the fourth character. So I should expect this to return 4. So you're going to tell me, yeah, I found it at the fourth character. So that's pretty good. Now, if what I'm looking for is not in there, so I'm looking for Nephi, which is not in the string, then it should return 0. And that's the way that this function says, you know what, it wasn't there. I didn't find it there. There's one more thing that we can do, and what we're going to see is that strings are, when you do string comparisons in VBA, this is like the main place that you're going to have things being case sensitive. You can capitalize your variable names differently, the names of your procedures. You don't have to have the capitalization right when you call a function. But when you do a string comparison, that's where it's going to be case sensitive. Well, it turns out there's one more argument here that I can specify to tell it not to be case sensitive. And that's if I say this is going to be a text compare. So again, it's using a built-in constant. Remember, this is just going to be some named value. So VB text compare evaluates to 1. But that says, you know what, we are going to say when I put a 1 here, which is what I'm doing when I put this constant there, it's going to say, all right, this should not be string case sensitive. So it should be, this should match now. So even though the case doesn't match, because I said we're going to do this with text compare, then it's going to say, all right, yeah, we found it now regardless of case. We're going to do some more with the inString function next time we get together, but it happens to be convenient for us to have today for doing the examples that we have. Questions here? Okay. So now I'm going to put an if statement in here. So if, and the syntax is if some condition, some expression that's going to evaluate to true or false goes between here, then we'll do something and if. And then whatever I have in between the if and the and if is what's going to execute only if the condition between the if and the then is true. And so what I'm going to put in there is this inString function. So inString starting at the first character, but now I'm going to look at the text of these violations. And the text is in column 2 of my data. So the second expression here is going to say, what am I looking at? And so I'll be looking at something different depending on which time I am through the loop. So far, so good? Now, what am I looking for? Well, let's say we're interested in rodent activity. I want to kind of see which of these dealt with rodents. I'll put rodent here. And because I'm not sure if the inspector would have put that in all capitals or would have put it, first letter capital, whatever, this is going to be VB text here, text compare as well. Now, this is going to return a number between 0 and the length of the string. But what I need between the if and the then is a value that's true or false. And so what could I do here to be able to have this expression be true if it's something more than 0? Because if it's 0, that's the way this function says I didn't find it. If it's 1, it means it found it right at the very beginning of the string. So I'm going to want to have this, which will be some number. I want to know if this is greater than 0. And come back up here and just do this. If up here, if I say if that's greater than 0, remember it found Nephi at 4. So that should be true. 4 is greater than 0. Right? So you can kind of think of this function in this whole expression. You can think of this being replaced by whatever value it returns. So it's going to return 4, and that's going to leave me with this expression 4 greater than 0, which is true. If it doesn't find it, so instead of Nephi, I'll put Lephi. If it doesn't find it, that will return 0. This then will come down to be evaluated to 0, and my expression that I have left is 0 greater than 0. True or false? That's false. 0 is not greater than 0. 0 is equal to 0. And so that will give me a false. So now this statement that I have right here will be true if whatever I put in here is actually found in the line that I'm looking for, the line that I'm looking at. So in that case, let me go ahead and print the row that I found it on, and I will print the actual the violation. So we can take a look at it. So there's a little bit of padding around this, but what we're really looking at here is this idea of conditional branching. Instead of executing all the code that we have here, we're going to look at this condition. A little bit of vocabulary here. Let me just be clear about it. So when I say the term expression in VBA, an expression is just any block of code that I can look at and say, that evaluates down to a single value. I can give that block of code, whatever it is, to the VBA interpreter, and it will figure it out. And when it's done, it'll go, yeah, I can figure out a value for that. It evaluates to a single value. And so is this an expression? Can the VBA interpreter look at that and evaluate it to a single value? Yeah, it's going to be some number between 0 and the length of the string, depending on what I have in here. Okay, so that's an expression. How about this? Is this whole thing an expression? Yeah, it can be evaluated down to a single value. What is going to be true or false? When I have an expression, any segment of code that can be evaluated to a single value, it's called an expression. If I have an expression that is either going to be a true or false value, it is a special kind of expression called a condition. So we say this is an expression. Yeah, it's an expression. Is it a condition? Yeah, it's a condition. Condition is an expression that evaluates to true or false. And so what you have to put between the if and the then is a condition, something that will be evaluated to true or false. And if it evaluates to true, we'll execute whatever is inside the if. Otherwise, we will just jump to the end if and move on. So before I printed all 300 or 298 rows, however many there were, now I'm only going to print the row numbers that actually include the word rodent in that column 2. So if I was to come here and just search for rodent, see one here on line 264. So we should expect to see 264 in the results. Let's go ahead and run it and see if that's the case. So there's 264. And a bunch of others. Kind of clear that out and run again. So So it looks like these guys are repeating what the statement is and then adding their comments afterwards. All my doors are now in good repair, violation now corrected and abated. That's good. So I guess this is they're re-inspecting the place and they're putting a note that says everything's okay. Whatever that place was, I guess I wouldn't mind eating there. Uh-oh, this one's a problem though. Comments. Over 40 mice droppings scattered along the wall. Do you ever just think, that you're, thank heaven that you're not like a food inspector and have to actually go and count, oh, look, there's 40. So they got to get that fixed. Okay. So questions on this simple version of the if statement. It turns out that when it's this simple, when there's only a single statement that I want to execute based on the condition, there's a different form of the if statement. And this is how it works. I can do this whole if statement on one line if, instead of putting this down here, I put it after then. And then I don't need the end if. This seems a little bit strange. I have if, some condition, then, and then I'm allowed to put one statement there. Why do they have this version? And the answer is they have this version of the if statement because back in the very early days of BASIC, this was the only version of the if statement. You couldn't do multiple lines. You had to do if kind of one line at a time. It was a terrible, terrible time. I lived through it. But we thought it was normal back in the day. So you may bump into this one, but I encourage you not to use this. Even if you have one line, I think you're probably better off saying, you know what, I'm going to bring it down to the next line, but now I have to have the end if. So if it's a single line if statement, no end if is allowed at the end. If it's a multiple line if statement, you've got to have the end if. But now we can say, all right, we can now add in another clause. Let me bring in an else clause. So the else clause says, okay, we're going to evaluate this condition. If this condition is true, execute the code that goes with it. As soon as we hit the else, drop to the end if. However, if this is false, then skip this code here, drop to the else, and then execute whatever's down here. So perhaps what we'll do here, why don't we go ahead and nest another if statement in here? I'll take this whole if statement, and I'm going to drop a copy of it right inside. And what we'll do is we'll say, all right, we're going to look for that first one. If we find it, we're going to print something about the rodent. Otherwise, let's print something about, let's look for, I'm trying to think of what else they might have in there, sink. So I think I'm going to print now row up here. I'm going to print row and then I'll print rodent just so I can tell which one we're actually seeing. And this one will put sink. What's going to happen if I have some statement that says, oh, you know what, you've got rodents near the sink. What's going to print? Am I going to get the one about the rodents, just the one about the sink, or both of them? Let's vote. Who says we'll get them both? Just the one about the rodent? Just the one about the sink? Oh, you guys are good at this already. Right, because if this is true, then we execute this one, and then we don't even look inside here. But that should give us some data. We'll see some dealing with the rodents, some dealing with the sink. I'm not sure if we have any that are rodents and sinks, but we can see rodent, sink, rodent, sink. Now, what if I wanted to look for yet another one? Well, if it's not rodent and it's not sink, maybe I'm looking for toilet. Well, I could do the same thing. I can put an else clause in here and then nest another if statement. And it turns out that this is such a common structure to be able to say, I'm going to look at something, and if it's not that one, check something else. If it's not that one, check something else. They made a special form of the if statement for it. That's called the else if clause. And what I do is instead of nesting these all with their own all with their own and if. Oh, here it is. Let me go back to the way this was. Or at least the way I wanted it to be. So if I find rodent, we'll print this off. Otherwise, we're going to look here. If I find sink, we'll print this off. There's no otherwise on this one, and we're out. But it's so common to say, I want to do check for this. If it's not that, check for something else. If it's not that, that I can pull this if right up here onto this line and actually make that into one keyword, else if. And then the same thing, we've got the condition here, then, but now both of these and ifs are the same part of this, now part of the same structure. So I only need one and if. But now I can bring another line and say, oh, I'm going to look for a toilet. Now we should see some of those for rodents, some of them for sink. Do we see toilet anywhere? One for toilet. Toilet room, door self-closing. And of course, we can put an else on this. And now whatever we put here, why don't we just go ahead and print the row number and then just say, I guess it's A-OK. So this is now, good question. How many lines is this going to print? Knowing that we've got 297 lines, how many lines will be printed by this code? The answer is 297. It's going to print every single line. Because what we're saying is, listen, if this condition is true, print the line. If it's not true, let's look at this one. If this one's true, print the line. Well, if it's not true, we look at this one. If that one's true, print the line. If that's not true, what are we going to do? We'll print the line, right? Every single line is going to get printed in this case, but these blocks of code are mutually exclusive. And so if I've got an else clause here, then it's going to print. Either it will print because it found one of the ones above it, or if it doesn't find one above it, it'll print in the else. Is there any possibility that two of these will print? I'm sorry, that a couple of these, first of all, is it possible that for a given line that more than one of the conditions specified here is true? Yeah, it's totally possible. But we're only going to actually execute the first one that it finds. Okay. So that's the if, else if structure kind of in all of its complexity, right? You can like nest other if statements in these. You can put loops on the insides of these blocks. You can do any code you want on the insides of these. By the way, the human processor can deal okay with about 2 levels of nested ifs. Once you say, you know what, I've got a 3rd level here, it's too tough for your brain to handle. If you do that, 2 things should happen. One, you should ask yourself, is there a way I could do this without nesting so deeply? And if so, try to make that happen. If not, you say, no, this is the best way to do it, and might be, then just you got to know, hey, I got to be really careful here because this is tough for the old human processor to deal with. The VBA interpreter loves it, just great. Couldn't be happier, but it's tough for us to understand. Okay, let's go ahead and do a different example. In fact, I'm going to copy this and we'll build on it. And I'm going to call this, instead of if, I'm going to call this complex. I'll call it complex condition. All right. Well, I'm going to look and see if I can find where we have one that says something about rodents and about sinks. And if we don't, we'll find something else that we can find that are both there. Actually, let's do this. Let's do for rodents and the word corrected. So I'd like to see rodent problems that have been corrected. So let me back this down just to my rodent one. And so I want where this is true and something else is true. There's a couple of ways that I could do it. Let me show you one way that is not the best way. I could actually nest another if statement inside of this and look for corrected. Even though it's all capitals, case insensitive, so that should be okay. So now the only way for me to print this line is if this is true, then we'll drop into this if statement, and then we'll hit this if statement, and then if this is true, we're going to get it. So I am going to run that one. We've got a bunch that have been corrected. Oh no, we don't have that many. We've got like 5 or 6 that have been corrected. All right. Okay, but you remember that what I said is that anytime you see yourself doing kind of multiple nesting, ask yourself, can I do this in a better way? And the answer is, in this case, yes. I can actually check for both of these together at the same time. So instead of nesting this, let me just copy the other condition out. And because this line's getting pretty wide, I'm going to use the line continuation character underscore. And then I will put here the keyword and. I think I'm going to put the and up before the end of the line here. And this. So in VBA, we assume that you're going to put one statement per line. If you say, no, we're going to do, we want to split this statement across multiple lines, I use the underscore character to split that, but the underscore character has to be preceded by a space. If this thing was to bump right up to the word and, that'd be no good. I got to have a space before the underscore character. So now the whole condition will be true, still a condition, but it will only be true if both sides of the and are true. And I lost what I was printing. Am I nested? No. I have a complex condition, but not nested. So that should print exactly the same thing, those same 6 lines. This actually, I think this is breaking onto the line because I think there actually is a carriage return character in the data. That's violation corrected, side door and kitchen, presently rodent or insect proof. Just curious to know if we ever had rodent and sink in the same one. Nope. All right, let's take a look at some of the different conditions that we have here that we can do to make complex conditions. So and we've got here. Let me just look at true and true. I'll just kind of look at it here. So there's and. If I have one of these as false, then this is going to be false, right? True and false is false. Do you remember doing this in like pre-algebra or some trigonometry class that you had in high school, a truth table? Did you do this? What if I flip the order? Does the order matter here? No, false and true can be the same. False and false is what? False, false, let's see. But let's go back to true. And of course, now we have or, false or true. So when you have an or condition, both halves, as long as one of them is true, the whole thing is true. So what if they're both true? Is that true? Yeah, that's going to be true. Turns out there's another operator here called exclusive or, XOR, which says, no. just one of them is true. So if they're both true, the whole thing is false. As long as one is false and one is true, this will evaluate to true. If they're both false, then that will be false as well. So there's exclusive or as well. Oh, there's some others that I think I read once and have never used. There's one that will lets you tell if they're both the same. So they're both true, it's true. If they're both false, it's true. I never in my whole life have gotten the urge to use that operator. So there must be a good reason for it. I just have never come across it. And these, by the way, can get complex. Is that expression true or false? Let me just do this, make it a little clearer. All right, we got to break it down one at a time. So I've got this or here, it's false on this side. So the only way this is true is if this whole condition is true. And this is an and between these. And so they both have to be true. Is this one true? Yeah, false or true. So it's true on this side. Is this one true? This one's false. So this is false. So this whole thing is false. So that's false. So I have false or false. The whole thing's going to be false. Will there be a question like that on the midterm? You can count on it. All right. There'll be something like that on the midterm for sure. Okay, and of course, these don't have to be just true or false. I mean, that's just so that we can type it easily. They can be conditions like this, like a whole long condition to evaluate to true or false. Okay, so that is complex conditions. So the good news is you can use a complex condition to keep yourself from nesting, and you should trade off. If you've got nesting and you can trade off with a complex condition, that's better. But realize too that the human processor doesn't do real well with complex conditions either. So there might be situations where you say, wow, I've got a couple of complex conditions here, and there's an and operation between them. Should I split those out and use nesting to kind of separate them apart? Maybe so. Yeah, this probably accounts, is it too strong to say for most of the errors in code that kind of make it into production happen because of either complex conditions or excessive nesting? Yeah, most is probably too strong of language, but probably not by very much. I mean, this is where errors happen. So you got to be careful with this stuff. All right. Okay, that's the if statement. Is there anything else about the if statement I got to tell you? So we've seen the if, the single line if, the block if, where you have an if and an else. There's one more thing I want to show you. So let me come in here and let's suppose that I have let's suppose I accidentally put the end if here after the loop. So if we look at the structure here, I've got a do that starts here and ends here. And then I've got an if that starts here and ends here. What do you think? Is that going to be legal? That is so not legal. And we'll take a look at why here in just a second. There's a question? No? But what I want to show you here is the error message that you get when you try to run this, because it doesn't look very good. That error says you've got a loop without a do. Do you have a loop without a do? No. I mean, you can look at it. You can go, wait a minute. There's the do. There's the loop. What do you mean loop without a do? Why is the error message loop without a do? Go ahead. That's right. It's coming along and says, okay, do. This is great. Beginning of a loop. I love it. It gets to the if statement and goes, ah, wow, complex condition. I'm feeling pretty good about it. Get to the then. And it's going, all right, do events, no problem. Row equals row plus one, no problem. It gets to the loop and it goes, I'm in the middle of an if statement. If this is legal, there's got to be a do also inside this if statement. And so, yeah, it's just because it tells you to do without a loop, it doesn't necessarily mean that's the problem. It could be that you've got the end if in the wrong place. This, by the way, and I've talked with some of you when you've come for help and I've looked at your code, and I'll always do the same. I'll always do this as the first step when I'm looking at your code. If your code isn't like kind of properly indented, that is to say that when I look at the kind of look down here from do down to loop, there's nothing that kind of breaks that visual line. Same thing with the if to the end if. Kind of get all that stuff tabbed in to be a part of it. Once we start nesting structures inside of other ones, to keep this straight, you've got to keep things properly nested. And as beginning programmers, you're quite often thinking, wow, kind of tabbing this stuff in is like one more step that I don't want to have to trouble myself with. But it is trouble that is worth the time. It's not that much trouble, but it's worth the time. All right, let's look at another structure. So let's see, I think on this one, I'm going to come back to my food inspections here. And why don't we just, I think I'll just change the background color of every one of these that says school. Kind of like condition, could do this with conditional formatting, but it's a reasonable example for us to do with looking at it at another statement besides if. Okay, so this is going to introduce us to the thing called the select. I think I'm going to use the same structure to control the loop. So let me get myself a loop up here. Get everything else. Let me get everything that's not part of the control of the loop out of the way. And instead of violation, now I'm going to be looking at the food inspection sheet, which is just called inspection. And I usually like to, when I've got the structure of the loop in place, I like to just run that by itself to make sure that that's working the way I expect it to be. So debug.print, you just print row here and see what that does, 77. So I should have 77 rows here or down to row 77, so that looks pretty good. Okay. So here, the syntax I need is select. Starts with select, ends with end select. So select, end select, and then up here with the word select on the same line, I'm going to say case. Then I'm going to give it something to look at. And what I'm going to look at is one of the columns on my inspection sheet that I'm looking through. And I'm going to highlight all the schools, so that's going to be E. The fifth letter, I could put a 5 here, or I could put an E. Whoops. Or I could put an E here, and I'll do the E just because it's a little easier for me to think about it in terms of its column number. So now, whoops, select case, inspection, yeah. What this says is I'm going to make several conditions back to this one. You remember down here in my if, else, if, I want to know if this thing contains road. If it doesn't, I want to know if it contains sink. If it doesn't, I want to know if it contains toilet. These are all different conditions from each other. And you know, the fact that they have just 0 on this side means we probably could do something similar up here. But when we're saying, listen, I want to look at a variable or an expression, and I want to do something different depending on what value is in there. So in other words, all my comparisons are going to come back to a single common value, and it's actually preferred that I use this select case structure. And it's because the syntax is a little cleaner to read in that case. So now I'm just going to come case here, and I'm going to say school. And then tabbed in from here if it's true, so now I've kind of split the condition. I'm saying if this is equal to this, then we're going to do something here. Let me just go ahead and do that. I'm going to say that that cell's interior dot color index equals, it is yellow. Is yellow 2? I don't remember. We'll make it 2 and see what it looks like. So now we're going to loop through all of those. And on each row that we're on, we're going to check to see if this expression is school. If so, we are going to set column E to be a different background color. Scroll over just a bit. I really expected that to go yellow. What am I missing? Oh, probably the background color index is, that's probably white. Let's go to 3. You see if I'm going to put a little stop here to see if I'm actually hitting that. I am getting that. Row number, what's row right now? So I was seeing this one. I'm wondering if that one is like have a space on it or something. Why is that one not going? Like you should know. I'm the one who should be telling you the answer to that. Run it again and see if it goes. I'm not sure what I did wrong. Anyway, that's doing what I expected to do. Well, red's not a very good color. I like green better. Okay. Now, if it's just this simple, I just use an if statement. But now I'm going to say, listen, well, if it's not school, I want a different color for something different. So let's say if it is a mobile food preparer. I wonder how many mobile food preparers we have. It's a mobile food preparer. I'm going to make it color 7. Let's do grocery store. And we'll make that 6. Oh, 6 is yellow. Okay. Again, like the if, else, if structure, these blocks of code are mutually exclusive. And so as soon as one is executed, I stop even looking at the other cases. But the reason that I choose to use this select case statement instead of if, else, if, is because this statement kind of jumps up and down and it says, I am making a bunch of comparisons back to a single expression. Whereas with the if, else, if, these are all independent. I can kind of compose whatever independent condition I want in between each of the if and the thens. They're not coupled together at all. Whereas in this one, it's saying, you know what? We're looking at one thing and we're going to do something different based on what the value is. Questions? Yeah.
I try to run it and it says compile error, do without loop.
So if you've got a do without loop, and you want to make sure that you've got your end select in here, that's kind of that same problem. If you've got a structure that's not properly terminated, it's going to be a little confused. I think if you were missing the end select, I'd expect to see a loop without do. Did that, do you see the problem?
I mean, it has end select as well. Yeah, the loop. Is that after?
Yeah, the loop is down here. Oh, it really was a do without a loop. Yeah, if you don't have the word loop in there, for sure, that's it. Okay. There's some other things that we can do here, and that is we can do things based on like if it's greater than or less than. So let's look at something that actually has a number. In fact, I'm going to copy this whole, I'll do another select demo. Select demo 2. This one, I'm going to look at like either the, let's see, latitude, longitude. Longitude is this way. Which latitude? Yeah, so longitude is how far east and west, latitude is north and south. So let me just ask myself, so what I want to do is I want to put different color, I want to put a different color on every single one of these, depending on how far north and south it is in the city. I got to have a little better feeling for what my latitude range here is, because, I mean, Chicago is not that big in terms of latitude. It's probably only 1 or 2 degrees across. So let me find out what the minimum of that is. So my smallest number is there, and the maximum is 42. Yeah, it's not even, it's 41.7 to 42. It's like 3/10 of a degree is how far across Chicago is. So I think, I guess, why don't we just kind of do that in, let's just find out how big that is. This equals this minus this one. And then let's divide that into 4 numbers. 4 groups. So 0.7 is, I don't know how evenly we're spread out among those, but that'll give us some variation. Okay, so we're looking at column N. So I want to change all of these to column N. Actually, let me back this down to just 1. Okay, so my smallest one is 41.70. So I want to say, so here I'm looking at column N, which is my latitude value. Now, I'm not going to expect to find anything exactly the same on the latitude, but I want everything that is less than kind of 1 segment above that, right? So 0.7, let me just take these. This is going to be that. This is going to be this plus and let's fix that. Okay, so I'm going to first find everything that's smaller than this number. So I'm going to say case is less than that number. So if it's less than 41.702, no, it's not, I'm sorry, it's the next to the one is the one that I want to be my first number. So if it's less than that, I want to set its background color to something. In this case, I'm just going to set it to different shades of gray. So instead of color index, I will do color. And remember that color index has like 53 values. Color has more than 16 million. And so instead of just trying to actually pick a number that's going to be a shade of gray, I'm going to compose that. So I'll use the function RGB, and I will give it then 3 different numbers: amount of red, amount of green, amount of blue. And so why don't we do this as, why don't we do this as 50, 50, 50, 50. 50, 50, 50. So it's going to look at the value that I have here, and if it's less than this relatively small number in the world of latitude, Chicago latitude, I'm going to make it that shade of gray. If it's larger than that, well, I'm going to look at the next one, which is here. And then that's going to be 100. Otherwise, we'll look for this one. That will be 150. Now, I can actually have a condition in here that is just like the final else clause in an else if. I can say case else. And we'll put that at 200. The range on this is only the 255, so we'll be pretty far across the range here. So now, if it's lower than this one, we'll set it to this and we're done. If it's not, we'll see if it's lower than this one. If it is, we'll set it to this and we're done. Otherwise, we'll check through. So we should get 1, 2, 3, 4 different color values here. If I'm not changing E, I got to be changing N. So now that gives me, well, just what we talked about, right? Depending on which one. Now, let's see. So we're looking at this one here. It's made anything, is it true to say that this is made anything less than this number equal to this color? No, because there are 2 other things that could have prevented me from ever hitting this one. So the order that I put these in is going to be really important, because we're kind of biting off a small piece of it here, and the ones that we catch with that in that small segment, we change. Now we're looking at the next little bit more, and so the order is going to be really important. Okay, questions? So that's the big thing about conditional branching. There's several variations of the if statement. Your other conditional branch is select case. And someone tell me what the big difference is between if, else if, and select case. There's one big conceptual difference here. Why would I use case? First of all, is there anything that I could do with the select case statement that I could not also do with if, else if? No, I could do anything that way. In fact, little work, I can make them completely operate for each other. But why then do I choose to use, what's the condition about my code? What's the characteristic of my code that says, oh, I should be using select case? They're all going to have expressions. Expression just means I can evaluate down to a single value in the back. Yeah, if I'm this may be what you meant on the front row. If I'm testing the same expression over and over and over again, right? Because this one says, all right, I'm looking at this, and based on that thing's value, I'm gonna branch and do some code differently. Certainly, I could do that with the if, else if structure just by repeating this condition, right? By repeating this expression. So I could do that same thing, but this one really says, hey, single value, and then evaluating up to it. Let's take a quick look over what I talked about last time I taught this. I don't think there's anything else in here. Talked about complex conditions. The one other thing to realize is that I can put whatever I come in here, this can be complex as well. So this could be 41 plus 0.78. So I can get any condition in here as well. So it's not just numeric values or string values. I can put, calls to functions or anything else that I want to evaluate in here, and that will work just fine. All right, folks, let's call that good for today. Thanks for coming, and we will see you on Monday. Class dismissed. I was